Alrighty, let's get this show started. So part of taking antiderivatives is just trying to figure out when do you use U substitution and when do you not. So maybe take a look at the old worksheets and just compare them side by side to see little subtle differences. Let's take a look. So always, change that thickness. Always a good idea maybe to rewrite with algebra. And I'm going to write this one a little bit differently. I'm going to move the coefficients outside and separate based on the pluses and minuses that are there. So remember, all these coefficients are there no matter what. And if you do it this way, you do have to write it correctly, but you don't have to do it this way. Just recognize that each term separated by plus or minus is a separate term, and you take its antiderivative separately. And I definitely need to look at that last one there to remember that that has a special rule. But let's go through it left to right. So coefficient is there, add 1 to the exponent, divide by that number. Coefficient is there, add 1 to the exponent. That's not right, is it? Let's erase that. Denominator 7 there. I'm getting my 2's mixed up. So add 1 to 2 over 7, you get 9 over 7. And then the last one, remember that exponent negative 1 is the natural log. Our antiderivative is the natural log. Alrighty. And it would be good if you can simplify that term in the middle there, divided by a fraction, but it's not necessary. Remember that simplification is helpful in typing in Excel. So let's look at this next one here. Now in the past, when we talked about U substitution, we talked about denominators, but think about it. We're going to take the derivative of U, and if you pick 5x squared, its derivative is 10x. Well, there's an x to the 6th in the top, so that's obviously the wrong choice. So probably this one may be some algebra, and then the derivative, then the antiderivative. So 10 divided by 5, 2, x to the 6th divided by x squared. All those laws of exponents from way back when I warned you about them. So that one simplifies with those laws of exponents, and then the antiderivative becomes pretty straightforward. So no U substitution so far. And you can write that last one as a plus there if you recognize it. Alrighty. So this one, a little bit different. We have a denominator, and that denominator has an exponent, that cube root. So that might be an indication for U substitution. So let's pick that. Remember, always pick the inside part, not necessarily the entire denominator. If it didn't have that cube root, we might pick the denominator, but we want to pick the inside part. Alrighty, and once you do that derivative, take a look at it and see what pieces are there. Do you have to manipulate the coefficient? And we don't have to do anything, so I'm going to rewrite this with the U. So the U's in the denominator, so let's go ahead and write that with the correct exponent. That's a cube root. And then the 4v cubed and the dv are all taken care of with our du like that. So we'll take our antiderivative, add 1 to the exponent, divide by that, plus k, and then substitute it back in. And I am going to deal with that denominator. So remember, when you divide by a fraction, flip it over and multiply. And then plug back in the part you picked for U, and you're good to go. And remember, anytime you're doing the antiderivatives, if you take the derivative, you should be able to get back to that original function. Now, with our manipulation of the exponents, it may look a little weird, so you do have to know those rules to be able to see it the way it is. Next page, scroll down. Okie dokie. All right, another fraction. This denominator does not have a giant radical over the whole thing. So let's go ahead and pick the denominator. And not exactly what we have, but you might notice that the 3q minus 6 is twice what we've got in our derivative. So let's go ahead and divide all this by 2. Had one similar to this in a worksheet, and I did a little differently on that worksheet, so you might go back and look at it to see an alternative way. Alrighty, so we pick the entire denominator as our u, so u to the negative 1, and then all the other parts are going to be du divided by 2, like that. And this is exponent negative 1, so that's our natural log. And always substitute the original variable back in. Oops, and I made a mistake, didn't I? Absolute value. The natural log is not defined for negative numbers, so when we do the antiderivative, we always have to use the absolute value. Next. Alrighty. This one looks a little complicated, but let's maybe write it with our algebra to take care of all the fractions and things like that. 2 is a coefficient, just goes out front. We've got 2 divided by x, so I'm going to write that. And then that whole thing is multiplied by x to the negative 2. And that may or may not help you see the choice for u and how it works, but it's helpful. Oh, what just happened? There we go. So my u, now we've got an exponential and a denominator. You know, if you pick a u and it doesn't work, then pick a different one. So I'm going to pick the exponent of the exponential and take its derivative. And I've got bits and pieces there, right? I don't have a negative, so I'm going to move that negative. Oh, I've got a 2. I don't want to move the 2. So I'm going to move the negative to the left, but I'm going to leave the 2 there because there's a 2 in my original. And I see x to the negative 2 and dx, so I'm good to go. So we're going to have a negative, and that 2 stays there. And then e to the u. And remember, if you've got an e, you should just wind up with e to the u, because we can't have anything else there. And I got another boo-boo. We don't want x's and u's together. There we go. So now the antiderivative, like that. As such. And this one is a little bit more complicated. Let's go ahead and write the double checking out so you can see that it actually works. So we want to take the derivative of this, and the derivative of k is 0, so I'm not going to write it down. So negative 2 is a coefficient. The e part stays the same. The derivative of the exponent, so that 2 there is a coefficient, and then that negative 1 goes in front, and I just don't want to write anything correct. Go back to the pen, and then x and subtract 1 from that, and it looks very different. So let's use our exponent laws. So there's a negative 1 on the right and a negative out front, so they're going to cancel. And why do I have a 2 there? I'm pausing because I've realized I made another mistake, because I'm not going to have a 4, am I? I've got 2 times 2, and this is why you do double check it. So I like the mistake. So let's figure out where that mistake is. Do you see it already? Where is the mistake? Oh, I see the mistake. I want over here, let's get another color. Ooh, and a big one. I've got a 2 there, so when I make my substitution, that 2 should go away, right? Because I'm replacing the 2 and the x negative to the power of negative 2 and dx with the du. So that's where my mistake was originally. But that's, again, why you double check, to make sure that you're doing it correctly. So I'm glad I did that to illustrate how to figure it out. Okay, so now we're going to have, go back to the black color. So the negatives cancel. We only have 1 2, because I didn't have a 4. That's how I knew there was something screwy. And then e to the 2 over x, and then the x to the negative 2 at the end turns into that. So you do need to know those exponent rules, and double checking every single time is good, because you never know when you're just going to write something down wrong like I did. I planned that, by the way, to illustrate it. That's all we got. So keep on trucking.